App component. A theory
So now you are
component
sharing.
as usual, the same. Huh?
So now you are sharing.
I shared that notes in our
Yes, sir.
display.
25 MCQs. You are going to share it now.
No, 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 no. That model exam, practical model exam.
So when it is,
You told na 16th
sir, but
July.
it's not all.
Huh?
From 16, it's going to start.
Yeah,
All
it's
this.
going to start. When
So
our lab time will come, that time.
okay,
From the 16,
okay, sir.
when the third day order will come, that time our test. Okay. And the model theory component, as usual, the theory component, you know that when they schedule, maybe it
The
is a common
22nd
means.
of July.
Yeah, it is a common means we can go for the code and draw, or else individual mean the individual stuff we can conduct in our Google Classroom itself. Okay, one thing. Another one, and CT4 component we are completing now. We are going completing the practical 50% over, remaining 50% of students will conduct next week. And the theory component, I posted the assignment question. You have to complete it that on or before the deadline, and except two students, because they given the seminar that for except the two students everyone have to submit it, right? Yeah.
Sir,
So
for Taiwan, how many marks are there?
5 mark.
Sir,
5 mark
per question, sir, per question.
per question, not given the mark. So at least you have to attend one or two question. Totally three question I asked now. So
Yes,
at
sir.
least you have to try to answer two question.
Okay, sir.
Okay, at least you have to answer two question. The maximum, sorry, minimum 3 mark I given to everyone. Only the 2 mark variation based on your answer, how you are trying. Based on that, the 2 mark, 5 mark, 5 out of 5. But everybody get 3 mark. That is a compulsory. Sure, in my observation. But that remaining 2 mark you have to answer it. Okay. Okay, this one we completed enantiomer differentiation between enantiomer and diastereomer. We started? No. Yeah, yes, student. Is there anything doubt in your internals? If there are any clarification means now I'm ready for the internal. Everything is now over. Okay, everything in your hand only. The assignment, viva, everything in your hand. That 10 mark. Once you submitted the assignment, that's it. I given the 5 out of 5. There is no question for that one. But you have to submit it on the time. Okay. Okay. First, we have to complete our attendance. Samil,
Present, sir.
Samil, are you here? Reshma,
Present, sir.
Ritesh, 144 Ritesh, Bala Maniginda, Ritesh
Present,
present.
sir.
Sir.
So 147 present.
Yeah, yeah. Rahul, Rahul, 148. Are you here? Arun, Okay. Rahul. Rahul. Piyush.
Present, sir.
Dhanush. 153. Dhanush. Vignaneshwar.
Present, sir.
Dhuru.
Present, sir.
Veeravardhan.
Brian, sir.
Mayank.
Present, sir.
Jayakrishna.
Present, sir.
Sandeep.
Present, sir.
Utkarsh.
Sir, present, sir. 165.
Yeah, present.
166
Utkarsh.
present, sir. Present.
Tejaswani.
166 present, sir.
Yeah, present. Tejaswani. Nikita.
Present, sir.
Okay. Katti Prabhas.
Present, sir.
Ayush.
Present, sir.
Shashi.
Present, sir.
Varun.
Present, sir.
Srish. Srish. Rashti Agarwal.
Present, sir.
Okay. Sivanesh.
Present, sir.
Sai Neeraj.
Present, sir.
Jay.
Present, sir.
Preetam.
Yes, sir. Present, sir.
2% came. Samyukta.
Present, sir.
Kush.
Present, sir.
Rajdeep.
Present, sir.
Karthik.
Present, sir.
Karthik. Sharan.
Present, sir. Sharan.
What happened? 2%. One.
Yes, sir. Two. Both are present, sir.
Sharan.
Present, sir.
Okay. Vaibhav.
Present, sir.
Rishi.
So he went for vaccination, sir.
Okay. Aryan.
Present, sir.
Mahesh. Mahesh. Mahesh, are you here? Okay. Mahesh. Chinmay.
Present, sir. So 194.
Utsav. Yeah. Chinmay present. Utsav. 194. Krishna Prasad.
Present, sir.
Puneet.
Present, sir.
Om Rati.
Present, sir.
Jaya Praveen. 198.
Present, sir. 198.
Okay. Sai Gokul
Yes, sir. Present.
and Lakshman Sai.
Present, sir.
Thomas Varghese. Thomas Varghese not here. Vish Goyal.
205 present, sir.
Okay. Aditya.
Present, sir.
Gaurav. 207. PM.
Present, sir.
Suraj.
Present, sir.
Okay, I read the absolute number 148, 153, 193, 174, 194, 204, 207.
So 194 present, sir. So 151 present.
194%. Okay,
Sir, 174 present, sir.
okay.
168 in chat box.
2072.
Yeah, 168 I given. 204. Okay, okay. Yeah. So yes, student. So is there anything doubt in that while you solving that RS configuration, which one I shared last time? So many example I given RS
No,
configuration.
sir.
Okay, so you can work out yourself. So definitely one question is coming from the RS configuration. Okay, now we can go for the enantiomer and diastereomer. Differentiation between the enantiomer and diastereomer. So the definition itself is one of the differentiation only. What is a enantiomer? That is a non-superimposable mirror image. That is called enantiomer. Okay, in our right hand and left hand, that is a enantiomer. Okay, and diastereomer. Diastereomer means is a non-superimposable, non-mirror image isomer that is called diastereomer. So non-superimposable, non-mirror image, and the enantiomer in the yeah, in the enantiomer molecule, we can do the operation. That means we can do the plane of symmetry, center of symmetry, alternating axis of symmetry. All the operation we can do it on the enantiomer molecule. But in the diastereomer molecule, we should not perform any operation on the diastereomer molecule. For example, sigma, CASN, everything is not worked out in the diastereomer. And the enantiomer, only one pair of enantiomer is possible. That's what right hand is there means left hand. That's it. Only one pair of enantiomer is possible. But in the diastereomer, more than one pair of diastereomer is possible. And enantiomer is optically active because that's why it is related to the sigma. Yes, somebody talking. Yes, somebody talking. Okay, so enantiomer is optically active. That means we can do the it rotate the plane polarized light, sigma, CASN, everything. But diastereomer is not like that. Optically inactive molecule. Okay, it does not rotate the plane polarized light. Okay, then you look at the example whatever I given here. Here, yeah, the first two example. You look at it here. The first two example. The first one is a word is there in the here in our right side. Okay, and word is there both of words is there in the right side. But in the second example, one of the words is there in the carbon right side, another one carbon right side. Okay, therefore this molecule is the diastereomer. Look at it. There is no matching. That means there is no mirror image of the first one, as well as there is no superimposable. Okay, it is not superimposable, as well as it is not a mirror image of the first one. Therefore the first and the second example for the diastereomer. Now similarly you have to look at it the second and the third example. Second and third example, you can keep the mirror image of second molecule, you get the third molecule. See, here the OH is there in the right hand side, but here the left hand side. Here hydrogen is there in the right hand side, but here hydrogen is there in the left hand side. Therefore right side and left side and right side. Therefore it is a mirror image of the second molecule. Therefore it is a enantiomer. I told you enantiomer means the mirror image of the molecule. That means it is the opposite. Okay, and 1 and 3, you check it. 1 and 3, 1 and 3, you tell me 1 and 3 is a diastereomer or enantiomer? The molecule 1 and molecule 3 in that set is a diastereomer or enantiomer.
Enantiomer.
How you can say that is a 1 and 3 is a enantiomer? It is a mirror image of the first molecule.
Yes, sir.
How come it is a mirror image?
So H is there. No, sir. Only one is there. So diastereomer.
Yeah, only one OH is there in the mirror image, but the second
Yes.
OH is not a mirror image. Therefore, that is a diastereomer.
Yes, sir. Yes, sir.
Okay, diastereomer. So you have to identify which one is the enantiomer, which one is the diastereomer. Okay, so that is you can note down the differentiate between the enantiomer and diastereomer. Example also. Example also. Enantiomer and diastereomer. Then some topics, that is a racemic mixture, racemization, enantiomeric excess. Racemic mixture. So racemic mixture means we have to prepare the racemic compound. That means the synthesis of an optically active compound produces a mixture of both the plus isomer as well as the minus isomer in a equal amount. That means what? 50 percentage of the plus isomer and 50 percentage of the minus isomer. Okay, that is called racemic mixture. Okay, we have to prepare the optical active compound. That optically active mixtures is present in the equal composition, equal percentage. 50 percentage of the plus isomer and 50 percentage of the minus isomer. That is called racemic mixture. Then racemization. Racemization means the conversion of an optically active compound into a racemic mixture. That is called a racemization. Okay, you got it. The conversion of an optically active compound into the racemic mixture. That means, for example, 2A. We have to prepare plus isomer and minus isomer. Here there is no equal composition, but we have to prepare the racemic mixture. That is a racemization. And enantiomeric excess. Enantiomeric excess means any one of the isomers is present in the excess amount. That means 80 percentage of the plus isomer, 20 percentage of the minus isomer. That is called enantiomeric excess. Okay, if any one of the isomer is excess amount compared to other, that is called enantiomeric excess. Okay, so is there anything doubt for the racemic mixture, racemization, enantiomeric excess? Yeah, please you can note down. Yeah, simple definition only. This is maybe asked in the 3 mark question. I think you know that in a code and draw they can ask the 3 mark question. Right, somewhere they ask the 3 mark question. So this is a places where we can ask the 3 mark racemic mixture, racemization, enantiomeric excess, everything. Then we can go for the conformation of N-butane. So what is the N-butane formula? How many number of carbon is there in the N-butane? N-butane, Jayapraveen, Jayapraveen, are you hear me? Jayapraveen, is this Goyal?
Yes, sir.
Yeah, N-butane. How many number of carbon? You are thinking?
Yes, sir.
Ah, you don't know? Utsav Anand, Utsav Anand. Okay. N-butane, you know very well that is a four carbon atom is there. Methane, ethane,
Can I
propane,
answer?
butane. Yeah, yeah, Utkarsh.
Sir, butane has 4 carbon atoms.
Yeah, that is a very simple question. I don't know why the people are not answering for student involvement. That's why the faculty asking the question. You have to come forward. You can answer it. Okay. Okay. Anyhow, thank you, Utkarsh. So N-butane is a four carbon atom is there. Okay, write it. For example, this is a methane. Okay. This is the another one carbon that is a ethane. So you know, as for the Sagar projection, Newman projection, we have to put the front carbon as a dot, back carbon as a circle. Did you remember the rules I given to you? The front carbon as a dot and the back carbon as a circle. So therefore, this is the first carbon that is a methane, and the second carbon is a ethane, and third carbon is a propane, and here the fourth carbon is a butane. Okay, this is a N-butane. Therefore, N-butane, you look at it, four carbon atom is there. So the remaining part is the hydrogen. Here on nitrogen, here on nitrogen, similarly, here hydrogen, and here also hydrogen. Okay, so I can show you the diagram. Wait a minute, because yeah. So are you looking? Yeah, which one I put the red color circle? That is a N-butane structure. What are the possibilities? Structure is there in the N-butane. Okay, so almost six structure is possible. In that, out of six, which one is a more stable configuration? So you know very well, more stable means is a less energy. Okay, less energy. Therefore, here 135 is the more stable when compared with the 246. Especially the 4 is very unstable. So that kind of structure is not possible. So look at it, 135 first. 135. So here I wrote it here very small thing. Here this is a ME. This is a ME, methylene group. Similar way, here also ME, methylene group. Okay, the methylene group present in the opposite. Okay, opposite. So therefore, you look at it. Suppose yeah, this is the first structure. The methylene group, the front carbon have the methyl group, and the backside carbon also methyl group. Both are is the same side. Therefore, that is a uh, sorry, methyl group is the opposite side. That is a more stable because the bulkier group is present in the opposite direction, 180-degree opposite direction. Therefore, the repulsion is very less. If methyl group present in the same side, therefore here the fourth one, this is the fourth one. Look at it here. This is the fourth one. Where it is fourth one here. See, look at it here. The methyl group present in the same side. That means the front carbon methyl group is hidden to the backside carbon methyl group. Therefore, and also the methyl group present in the same side. That means upward direction. Therefore, it is unstable because of due to the steric entrance of the bulkier group. It is unstable. It is quickly come to the first structure only. Therefore, the first structure is more stable when compared with the um, 246. Okay, 246. And similarly, even third also the methyl group present in almost a 60-degree separation, but it is a more stable comparatively. This is also okay. So when 1, 3 and 6, the 1 is a more stable, and 2, 4, 6, the 4 is a very least unstable, sorry, unstable molecule. Okay, so now we can go for the discussion. Yeah, so this is a conformation of n-butane. Conformation of n-butane. So in these molecules, two distinct conformations are possible. One is the methyl group eclipsed by methyl group. That is one conformation. That's what I told now. Just now we discussed the fourth structure is unstable because of the methyl group is eclipsed by the methyl group. And the second, one of the methyl group eclipsed by the hydrogen atom. One of the methyl group eclipsed by the hydrogen atom. So look at it here. This is the first one, and this is the second one. This is for the eclipsed conformation, and the staggered conformation we explain later. First we can complete the eclipsed conformation. So think about it. This is one, and this is two. Okay, so for these two eclipsed conformation, one having the larger methyl group eclipsing will naturally experience more repulsive forces than other. See, look at it. Here the methyl group is there. Here also methyl group is there. So that methyl group is eclipsed. Therefore, automatically more repulsive forces is there. Therefore, that is unstable. When compared with the methyl group, is eclipsed by the hydrogen atom. Okay, because this is it is a less steric entrance when compared with the front carbon methyl group. This is a less steric. Hydrogen atom only is a small in size, but in the methyl group, a bigger size when compared with the hydrogen. Therefore, the methyl group eclipsed by methyl group is a very unstable molecule, and a methyl group eclipsed by the hydrogen atom is comparatively stable. Okay, this is for the explanation only for the eclipsing molecule. So now likewise Likewise, it will be two different staggered conformation. Two different staggered conformation. So what is a staggered conformation? Eclipsed conformation means you should not look at the backside molecule atoms. Staggered conformation means you have to look at the backside molecule also. So for example, this is a this is a eclipsed conformation. Eclipsed conformation, right? This is a eclipsed conformation, but this one is a staggered conformation. See, you're looking the front carbon also, you're looking the back carbon also. That is a staggered conformation. Okay, so one methyl group are at angle 60 degree to each other. That is called Gaussian conformation. So you look at it here. In between, one more conformation will be there. The methyl group present in the 60-degree separation of the backside methyl group. That conformation is called Gaussian conformation. Okay, Gaussian conformation. Therefore, the two is a more stable because of less repulsive forces will lead to the less energy. Therefore, in the staggered conformation, compare with the first structure, the second structure is more stable because of the methyl groups are present at 180 degree. So that is called trans conformation. Yeah, anything doubt is there? So you have to first you have to draw the structure of the n-butane. What are the possibility? I told you the six structure is there. First you have to draw that six structure. Yeah. First you have to draw this six structure. Then we will discuss about the which one I put red color inside the circle that you have to draw in your notebook. Okay. All possible six structure you have to draw in your notebook. Six structure is possible for the n-butane. Out of six, which one is more stable conformation? So here, what are the structure we discussed? Staggered conformation, eclipsed conformation, Gaussian conformation. So here staggered conformation is more stable, then Gaussian conformation, then eclipsed conformation. This is a order of the stability of the n-butane. Okay, order of the stability of the n-butane. Are you completed? And the number wise, which one is more stable? 3, 5, 2, 6, and 4. Okay, 1, 3, 5, 2, 6, 4. So this is a number wise. The first one is a more stable, then third one, then fifth one, then 4, sorry, then 2, then 6, then 4. The last one is the 4. Then you have to write it now, the explanation. Why the first compound is a more stable? Because of it is a trans conformation. Okay, because of it is there in the trans conformation. Look at it here. This one. This is a trans conformation. Yeah, this structure is a more stable one because of it is a methyl group or 180-degree separation, that is called trans conformation. That's why this is a more stable in the N-butane. Okay. Yeah, that's it. So is there anything doubt you can ask me now? So almost we are traveling in the fifth unit. Okay, the fifth unit also shortly we can finish it, because hereafter only the isomerization and the organic reactions only is there. Other than that, everything we completed. So only the fifth unit we are traveling. You have to submit the assignment. So the time is there. We will discuss that assignment also. No doubt.
No, sir, not there.
Hmm. Okay, that means only for you have to wait for 1 minute, then you can leave. Okay, okay, you can leave. Thank you very much. We will see you tomorrow.
Thank you, sir.
Thank you, Pa. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.